All right, hello students. This is our two-stage rocket, two-stage UAM problem-solving handout, right? Goes along with the simulator, which is right here, or interactive as you might call it. First thing you should do, if you haven't yet, is just play around with the sim. All right, I'll give it a click. We'll open it up real quick. It's on the physics classroom. Take a look at the features that are there. Feel free to pause me and just go mess around with what's here. It takes a moment to load. Some students have tried doing this on their phone, and you can definitely do it. I've had just a couple students say, over the past couple of years, that every once in a while they have a trouble with this on their computer. It's pretty rare, but it does happen from time to time. If that's the case, you can do the simulator on your phone. Usually works pretty well. And then do the handout on your computer. All right, so you have kind of two devices going. You can make this full screen by clicking here, or you can click on this arrow down here at the bottom right and just kind of drag and make it large. So that's what I'm going to do. You'll have lots of data here. One, we see what the stage is up in the left. We actually see the rocket take flight here and then come back down and eventually explode. We've got a velocity time graph here with meters per second on the left, time on the time axis. And then we have a position time graph with meters and height, just meters, and time. And then also a bunch of data in here. So I'll hit play, and off we go. All right, so it's at stage one, and then you notice the flame gets smaller for stage two, as does the acceleration, right? The slope of the velocity time graph gets shallower, all right? And eventually we're going to run out of fuel. There we go. Notice that the rocket continues to move up. I know this graph is going down, but that's just the velocity decreasing. It's still positive. It's still going 20, now 10, now 0, and notice it's starting to slide back down because now it has negative velocity. A lot of students get tripped up on that. You can also see the position starts to get negative, and eventually it explodes. So you can get all your data from this. If you want to get specific data, like at what time did it reverse its direction? Well, you can click once, right? See what I'm doing there? Or you can hold, and eventually you get to a zero velocity. There you go. And you can see at what time that occurred, what the acceleration was there, all that stuff. All right. Also, some students get a little bit tripped out. They go, let me back it up a little bit. They go, hey, doesn't it start going down when it runs out of fuel? Well, no, right? If I take this and I throw it up, the moment it leaves my hand, right? So I throw it, and the moment it leaves my hand, it's still going up. Eventually it stops and it starts to come back down. But the moment I start putting a force on it, right? The moment it leaves my hand, I'm not pushing on it anymore. That's like it's out of fuel, right? It has now run out of fuel because I'm not applying a force. That's what the fuel does. It burns, and that's the force that the rocket feels. So it still moves until it stops and then reverses the direction. And that's it's called free fall, the out of fuel part. And the acceleration it feels, notice it's negative 9.8. That's because of that G word, gravity. All right, so you've seen how to navigate things. Let's go back to the document and let's talk about each question. So first, you want to say where does stage one begin and end? Well, stage one starts at time 0 and ends at whatever time it says on your graph. There's like 3 or 4 different graphs. So if you refresh this simulation, you'll actually get a different graph. So I suggest don't do that. If you did, you can refresh a few times until you get the one that looks like yours, and then just keep it. And I think there's only 3, maybe 4. The ending time for stage 1, let's say it was 4 seconds. Well, that'd be the same as the beginning time for stage 2, okay? Because the end of 1 is like the beginning of the second. And I went over that in class. What else? So like these ones say, in what direction, up or down, is the rocket moving at each of these times? Well, pretty much for all of them, at 3 seconds, the flame is still on, so it's still accelerating up and moving up. Ooh, excuse me. So you just have to put up. And then down here, which way is the acceleration at this time? Well, it's still accelerating up. And you can tell because the velocity is getting, oops, I can't type. All right, because the velocity is increasing in the positive direction. You got to do this for all these times, and you'll notice that at some points, the object is moving upwards but accelerating downwards. And remember what that means? Right? When acceleration and velocity are in opposite directions, it means something is speeding up or slowing down. You tell me. The answer, slowing down. All right, let's make these. Oh, all my errors. All right, there we go. Make them go away. So then the next thing to do is to answer some questions here. All right, for number 5, and then scroll on down. There's a bunch of multiple choice questions. And for these, like, let's say that you thought A was the answer for number 6. You could just, boy, I'm not doing very well here. My computer's kind of slow. You could just highlight this and you could turn it all, green or something like that. All right, and then I can see, oh, okay, that's your answer. That's the one you chose. Cool. All right, so that's how you can do that. Easy. Okay, moving along. Multiple choice. Just, think about each of these scenarios as they're listed. And looks like I made a little mistake. Oh yeah, the velocities. All right, moving along. At what time does the rocket change its direction? Well, that's when it stops moving up and starts moving back down. So you can get that from the graph. You can watch the little section that says velocity right here and see where it hits 0, or you can just look and see what time is it that it crosses the 0 line on this graph, because that's when it's going to go from moving at the positive velocity. Remember, everything up here is positive, and everything down here is a negative velocity. So when it gets 0, it's changing direction, and you'll see that as it's moving here. All right. What is the acceleration value of the rocket at its peak height? All right, so the highest spot, what's the acceleration? It's a number. It's got a sign. Make sure you write whether it's positive or negative. What's the velocity at its peak height? Think about that. Right? At its highest point, how fast is it going? Next, observe the acceleration during no fuel. Is it constant or changing? So this is like once stage 2 ends, what is happening with the acceleration? What direction is it, up or down? And what's the number? All right, so 3 questions. Is it constant or changing? So you either write constant or changing here, up or down, and then, 5, -3, whatever the number is. All right, here I'm asking you to sketch the graph of your rocket's motion. You can draw this if you want, or simpler thing to do is just to go here and do the Control Shift and that little button that's above the 6 and just make a copy. Oh, you know what? I highlighted too much stuff. Let me try that again. It's just supposed to be the velocity time graph. So just take a copy of this right here. Boom. That's all you need, right? So copy that to your clipboard. All right, so I do this, and then on my Chromebook, at least, it does this. You copy the clipboard, and then you can come over here. You could take this picture, all right, select it, and then say, I don't want that. I want mine. And paste over it. Boom. There you go. Done. All right. So that's pretty simple. You can also insert a drawing, which is the instructions that I put there. Lots of ways to do this, and then you need to label the different stages. Right? So where's the end of stage 1? You can see that on the lines. Stage 1 looks darker or thicker than stage 2. When crossing the velocity time axis, all right, when does that happen? At explosion time, when does that happen? So this is just helping you identify all the different things that are occurring. For this one, you got to put a dot where the rocket changes direction, and so you can open up this thing in the drawing. All right, so you can go here. Oh, just kidding. Here, there it is. Well, it's in insert. Click on drawing, and you can open it up. The instructions for that are right here. You got to figure out the slope. Remember, slope is rise over run. So you can find the slope of all three of the lines. So if I was trying to do that, say for stage one, well, here's what I would do. All right, my initial point here is 0, 0. And the end of stage one, it's hard for me to see where that is. So let's go check. It looks like it's about 4 seconds and about 38 on the height. You'll know because the acceleration will change. All right, so there it is right there. So 4 seconds and a velocity of positive 36. So rise over run, so that'd be 36 over 4, and the slope would be 9. All right, and that actually makes sense because you can see the acceleration is 9, and acceleration is the slope of a velocity time graph. So simple. I actually didn't have to calculate anything at all. I could have just got it right there from the graph. So tricky. See, it tells you to calculate it, but you can just look it up. It's not that hard. All right, so you got to compare the slopes of velocity versus time to the acceleration. And the idea here is that you calculated the slopes there, and then you look at the slope and you go, oh my God, they're the same. All right, this is that time when you're supposed to make that realization that they are the same. What do you suppose the slope of a line on a velocity time plot represents? Well, see, so this is where we make the connection. You're supposed to write down, oh, my bad. For some reason, this question is supposed to be up here, and it got moved down. There we go. So it's supposed to be connected to this. So what do you suppose the slope of a line on a velocity time plot represents? Well, it represents acceleration. All right, that's why these two things should end up being the same. Just like the slope of a position time graph represents velocity, the slope of a velocity time graph represents acceleration. Okay, so here's another cool thing. So you're going to find the area underneath the graph for stage one, stage two, and the no fuel stage. This is also asked in the quiz, so you're going to see this kind of concept twice. So how do you do this? Well, let's talk about how you do it for stage one. All right, so for stage one, if I want to find the area underneath the line, so the area between this dark line and the 0 axis, what shape is this? And if I was going to turn this into a shape, it'd be a triangle, right? So I'm moving my cursor up and down along this kind of blue line, and now I'm moving it horizontally on this black line. And if you could imagine me filling in those lines, that would be like a triangle, right? This kind of shape. Actually, other way. This kind of shape. Did I just do the same thing? This kind of. There. All right. Genius. All right, so that kind of shape. So how do you find the area of a triangle? Well, if you're not sure, you can look it up, but it's 1/2 base times height. All right. 1/2 base times height. So let's make that go away. So I just need another base and the height. Well, actually, we already talked about that, right? The base is 4 seconds and the height is 36 meters per second. So that'd be 1/2 or 0.5 times 4 times 36, and that's 72. So that's the area. And let's see, we were multiplying seconds by meters per second. So that's the seconds cancel out. And what's the unit? Oh, it's meters. I wonder. 72 meters. Wait a second. Look at that. Look right there. The height is 72 meters. Oh my God. Sorry, it's a little bit late and I'm being kind of sarcastic, but there's a connection there. All right, so you're going to find the area under stage one, the area under stage two, the area for the no fuel part. That's where the velocity graph is going back down towards 0. And then also you'll find the area for this piece here. All right, so that'd be from like right here over to here and then down. All right, so it's kind of like an upside down triangle now. I'm not going to try and make that with my hands because the first time was a disaster. So now you want to compare all the areas. I'm going to add them up. It says to write the height. All right, so like for my first one, it was 72. And the area under stage 1 was 72. Okay. The height at the end of stage 2, I would go like this and wait for a little while. Do, 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 do. There. Okay, right there. So height is now 682 meters. I got a lot higher. And time is 14 seconds. So if I was going to find the area under here, I'd actually have to do 2 shapes. I remember doing this. I have to find the area of this rectangle. All right, so this gets a little more complex, and you probably want to put this on a piece of paper, but it would be 2 parts, and I'll just put them up here. All right, so the first part and the second part, I'm going to put them in parentheses like that. All right, so, oh, well, I'll just do it again. So basically, here's what I'm doing. I want to figure out the area of the rectangle. It's going to end here at 14 seconds. So that's nice. I'm going from 4 seconds to 14 seconds. So I know the base is 10 seconds, right? It's the heights that are a little bit tricky because they're not like 10, 20, 30, 40. So the height of, there's a rectangle that goes from here across and then goes up to, oh, sorry, I went too far. It goes to 14. So let's start over. It goes from here down over to 14 and then back up to 36. Okay, so there's this rectangle. So that rectangle, the area of that would be the base of 10. And then you multiply by 36 was that original height. All right, so 360. Okay, that's the area of that part. And then for the triangle that goes from here to 14 and then up to a height of 86. So remember what the height was here at the end of stage 1. Remember it was 36? And so we're now at a height of 86. Sorry, I said that wrong. The height was 36. I keep saying the word height. The velocity was 36. And now the velocity is 86. So the height of this triangle, all right, is the difference between 86 and 36. So that's 50. That's kind of nice. So 1/2 base times height is going to be 0.5 times, what did I say? 10. That's the base times the height, which was 50. So that's 250. So we take 250, and then the other number we had was 360. We add them up, and we get 610. All right, so that's the area under that one. So I'd come back over here and say 610. Let's see. So 610 was area 2. All right, so area 1 was 72. And then area 2 was 610. And the total of that is 682. What's the height? I got to look it up. Look at this. See, right here? The height at this highest point, or sorry, the height at the point where at the end of stage 2, it's not the highest point. It actually gets higher. See, it keeps going up and gets higher. So, but the height at the end of stage 2 is 682. I'm noticing a pattern. Keep going, though. See what it is. All right, so what do you suppose this means? This is the end, all right? This is the aha moment. There's a quiz. You can take it right here where it says take quiz. And a lot of the questions are pretty straightforward. I'm just clicking stuff. I wish I could get to the end faster. But there are some questions where they ask you to find things like the area underneath a part of the line, right? So they ask you to do this stuff. And so you can try that skill again. I'm not going to give away what it means, but you'll see. And then we'll talk about it next class. Okay, that's it. If you have questions, you can send me a question, or you can say, hey, Mr. Alexander, I don't know what to do on number 17. And hopefully you just come here and figure it out based on what I said. But if I didn't explain it well enough, then let me know. Send me a message on Schoology or on the Remind app, and I will write you back. Okay. Have a great day.